Hey, quite a bit of announcement to talk about, to remind. Okay, let's just get one by one. Just talking for Joven. So any one of you who might need another member for your team, I'm pretty sure Joven is going to be a very valuable member to have. Please, at the end of the class, come to the front if you want another member. If you know, I got to do something else for Joven, but we'll see. Please, no pressure. But if you already got 4, that's okay. Okay. And for your programming test, confirm for the venue. Lassonde 1006 is going to be the large lab on the ground floor, the largest one. You guys can sit very comfortably on Saturday. All right? And the time will just be the same as we confirmed, no change. Okay? Hilariously, the exam is scheduled to be the same kind of time on Saturday, on December 10th. And this year, I think our exam is quite early because I'll give you some context. Our last class will be Tuesday, December 6th. And the exam will just be about 4 days later. So I'll see what we can do. I know you guys got very limited study time, so we'll see what we can do. Okay, and we'll see if we can have some review session as well, maybe between the last class and the exam. I'll give you guys maybe some tips as well. Okay, well, we'll talk about it, but at least mark down the date for the exam. And the calendar, I want to speak about it. So I will put this updated version just after class today. Don't worry, it's just to reflect about the milestone for the project and also for the assignments. Remember, we just got quiz number 2 last week on Thursday. For quiz number 3, 4, and 5, I haven't changed anything. Let's stick to Tuesday, which means that quiz number 3 will just be next Tuesday. So I will confirm the coverage about quiz number 3, most likely just about a CFG. Although we're going to cover some design pattern today, which will be nice. Okay, anyway, I'll confirm for sure tonight. And we released the project already. And after your programming test on Saturday, I'll release your assignment number 2. And then you still got enough time, about 2 weeks to do it. And also assignment number 3. All right? Okay. And that's a calendar I want to mention. You definitely get a copy after today's class. And for quiz number 3, next Tuesday, I'll also confirm about the coverage later. And for project specification, I think we should really go over them together. Right? If you guys got any concern, any questions, I'd be more than happy to consider right now. Okay, why don't we go over them? Okay, here. So the due dates I put was December 6th. That's kind of the official last date for you to submit a work for the fall semester. So I think given that our exam will be on the 10th, it will be good for you to get it out of the way on December 6th. All right, so that will be just about the policy. And thanks to Henry, who found a typo. I'm going to fix that as well. All right, thanks a lot. And I would say while we're still officially in the semester, don't really make the project public. Right? You don't want to run into any plagiarism issue when we check. Right? But after the semester, I would encourage you to actually put this project maybe on your CV, on your resume. I think it's actually kind of cool. You actually be able to compile it for that. Okay. All right, let's talk about it. And any clarification, I'll make them under amendments before the end of the project. All right, just about the teamwork. I don't need to just repeat, but guys, I think you will be working as a team. So please, if there's any frustration, any tension, I've heard many other stories, in other courses. If you really want me to resolve them for you, I'll try my best, but reach out to me early, not like a 1 day before the deadline. Very little I can do. All right, but hopefully you guys will just make friends and carry that relationship beyond the course. That'll be nice. Okay. All right, so the only background reading you will need will be the Antler 4 plus the code coverage criteria that you have to study a bit. Okay. And for the context over here, you guys can read it. I don't need to repeat. I just want you to know these are the list of criteria you will need to consider. Of course, you don't necessarily have to do all of them. Well, of course, if you happen to be able to do all of them, we'll judge, and then you might just get a very high grade. But to just get an acceptable grade, well, of course, I haven't really decided what acceptable really means, but I think there's some minimum you need to do in order to pass the project, which is not challenging. You are given 6 weeks to do it. And I only included some example references about the definition for these coverage criteria. So I would say you can definitely look up for other references. So at the end, you're going to submit a report. So if there's any other extra references you look at about the definition, you can include them just in case we need to see them. All right? All right, so far, that's OK. And just make sure you understand why we are doing this. So later on, if you got interviewed by this talk about this project, that's kind of the context information you can mention. You're really doing something that's very useful. Okay, so let's now talk about the different tasks you should do for this project. Right? Let me just go there. And this will be the compiler you're going to build. Of course, it's going to be initially generated by Untitled 4. And don't be too surprised if you have to keep regenerating using the .g4 file to, maybe every time you update your grammar, you will have to generate. And make sure you always keep a backup of the generated file if you want to. So I think GitHub might be the nice way to actually keep track. For that one, I don't require that. So you guys decide what's the best for your team. Okay? Oh, one thing about the team, I really hope it's not going to happen. It's possible maybe your team member might just decide to drop at some point. It might happen. So you guys just want to make sure you really keep track of everybody, right? That's important. All right, let's talk about what you should do very quickly. You will need to design conceptually 2 languages. One would be for the input program. The other one would be for the input test. However, I would say it would not be surprising if these 2 happen to share lots of syntax together, may share some syntax together. That's OK. But what's going to be different from your Untitled 4 tutorial is like this. You're not just going to take a single input file. You may have to take at least 2 input files. That's easy to adapt from your main method. You guys can look into it, given that you're already in the 4th year. But if you got any trouble, you can also reach out to me. You will have maybe at least an input program and also the test program. And if you like, you can also design some extra syntax for configuration of the test. And for that one, I really have no suggestion. You guys can Google a little bit to see how people do things. You can feel free to copy the feature you like and design a grammar accordingly. That one is OK. All right? OK, you might also have some configuration for the test. And the compiler. And then what you're going to generate over here. So I would say this is not a very conventional compiler course project. Usually they say, OK, given C, you want to generate assembly. Well, given Java, you want to generate maybe Python. We're not doing that. We're doing something that's actually more modern. Your compiler is actually somehow going to simulate at the runtime how the test code is going to exercise the different fragment in the input program. And then after that, it's going to summarize the coverage in the HTML. Rather than saying the HTML itself is going to simulate the behavior of the input program. That's not what we're doing. All right, so once again, you're going to simulate how the test is going to be executed on the input program. And then decide the coverage according to the matrix you decide to adopt, and then summarize in the HTML. And for the HTML, the minimum requirements will be just something like an index.html. That will be the minimum you have to generate. And of course, I would say how fancy you want to make the HTML file to be is completely up to your judgment. If you want to make it very user-friendly, you may even have hyperlinks. Maybe you can navigate between different files. That'll be awesome. Impress us, the grader. But if you really just want to stick to maybe some very plain text without generating any let's say graph, we'll still judge accordingly to see. Maybe you have covered so many criteria, so you didn't have time to really polish the HTML output. You'll explain that upfront in the user manual, so we'll judge. And when the TA and myself are going to grade, we're going to launch, first of all, launch the output in the web browser to get a feel about how much you have really achieved in 6 weeks. Conceptually, do you guys have any questions? OK, let me dive a little bit deeper about this part here. And the very simple example, deliberately simple over here. I'm hoping that this is not what you will achieve in just 6 weeks. That'll be too little. All right, but let's get the idea. This will be some input program. You can see I'm not following exactly Java or C syntax. I just make it up myself. Of course, you're going to make sure you design the grammar for that. So this will be the program, and this will be the input. Think about what's happened is going to be this. Somehow this is going to be some AST1 and also AST2. And then in the antler 4, once you got these two ASTs, you're going to use this AST2 to somehow see exactly how AST1 will be covered. For example, by lines of code or by different statements. That's something you will have to figure out how to do it, to simulate. And another term to use is called interpret. Or you can say simulates. Either way. Not surprising because this course, actually part of the title is interpreter. So in some way, you're doing interpretation to see how much the test can really cover the source program. Okay? And this will be some example output. You can easily do some Unicode on the HTML. Or if you want to do some bar chart over here to show how many percentage. And also, between different criterion, you may just want to use different tabs. Click on that, you're going to see some different matrix. That can work too. But you guys can just be creative. We'll be quite happy to see different team actually got different achievement. And by the way, for this project here, we don't really have any presentation components. But that's something we can consider. Maybe I can ask you guys a little bit later. If you feel so confident you want to let other people know what you have done, we can also schedule some optional time for people who are interested to attend, to go over your presentation. I think that's nice. Anyway, that's only for extra. All right, guys, are you okay with this about what you need to do? Okay. And there's one thing I would suggest. In the beginning, I would suggest try to focus more on variable assignments, which definitely involves different expressions. And of course, expression can be Boolean expression, integer expression, or even pointer expression, depending on what you want to support. Start with this, and then do if then else, kind of conditional. I would say start with these. And later on, if you want to get more complicated, more useful input program, you can start supporting loops. And then you do loops. And for the loops, maybe starting from the beginning, you may not want to support just a very general while loop. Because somehow, I can tell you it's a halting problem, right? Because if a user simply specifies something that wouldn't terminate over here, that means the simulation of your compiler is not going to terminate. That's bad, all right? So you guys may just want to start with something called bounded loop. I'll give you one example. I want to make it a little bit more explicit right now. Okay? So for example, it's something like this. You can say for integer, let's say I don't know, I'm making that up, from some lower bound, maybe 10 to maybe 20. You can make maybe this from and this to, and also for to be keywords in your language. And you're simply saying this iteration here is always going to terminate, and it will go for exactly 11 iterations over here, right? Just an idea. Okay. But for the milestone, you're not really required to actually do any loops. Just for the milestone, it's really the minimum to make sure you're on track. Okay. I'll also give you some feedback. All right, guys. Any questions so far? You okay, right? All right. And if you haven't read the specification, I will encourage you to do that as soon as possible, so you can discuss with your team. And either you can use the visitor or the no listener version. There's no requirements, whichever way you prefer. Okay. And then let me see. I talk about all of them. Let me see. Okay, this one here about the documentation. This task number 4 is only due for the final submission. And I will make sure I will give you a template for the report. I mentioned certain dates somewhere, only for final submission. And I think you definitely got enough time to actually use a template to write a report. I can tell you already how the TA and myself are going to grade your project. I can tell you. Number 1, we're going to check to see the 10 working example you really submit. We run your compiler on the input file one by one and make sure the output is really what you claim to be. number one. If any one of them crash, that's too bad, right? And second phase. That's why your documentation is so important. Okay, I'll write it down. So you guys got some record over here. Part of the grading. Let's say grading of your compiler. Part of it. Okay, I'll say part of. It's not all, but part of. Okay, number one, we're going to run the example supplied by you. And the second part is really the moment of truth. We want to make sure you don't really hard code your compiler just for those 10 examples. That'll be too bad, right? Like even modifying from I to J can crash your program. Oh, that's really bad, right? So I would say for number two, I can tell you already, it's a fair game. I'll tell you how we're going to do it. The TA and I, we're going to modify the 10 examples you got. Maybe by adding a loop, maybe by adding some if statements, and then try to see if the corresponding output is going to be consistent and wouldn't crash. Okay? We're going to somehow modify or create example based on A, your supply example. And B, support the syntax that you claim. For example, let's say you claim that in your language you can support pointer. We think, oh, that's great, but somehow your example didn't really cover that. So we'll try to modify your example by adding pointers to it according to the syntax you suggest. If it can work, wow, it's definitely a big plus to really bump you up, to the next level. If it doesn't quite work, then we'll judge to see how bad it is, right? So that's why it's so important later on when you write the documentation, you want to make sure exactly what's being supported by your compiler is so important. And any limitation, any assumption we should make, you should also mention that, right? You'd rather not me and the TA finding out the limitation for your compiler, right? That's kind of like a general guideline about how we're going to grade. Of course, there might be other criteria as well. Okay, for requirements, yeah, that one is also to be fair to everybody. So I would say only for the HTML rendering. So let's say if you actually want to use some package or library for drawing some plots or graph, that's okay, no problem. You can feel free to use them. However, for the simulation of execution and also to really determine, how the coverage, code coverage is really, the matrix is satisfied, that part should be really built from scratch. For example, if you simply find some third-party library which will do the coverage criteria for you, that's not good. You're not supposed to. Everything should be built from scratch. Of course, you can use a hash table, array list, any data structure as you wish. You can even build your own data structure if you wish. And I'll give you a little tip. For the compiler, hash table is very important. It's already actually very relevant to your coming programming test. If you recall what's being asked by the practice test, if you got certain variables that will be modified, let's say a number of times in a single method, how can you know which the final value is for that particular variable? What you can do is having a hash table storing from variable to its corresponding value always. Every time you have some updates by assignments, you can change the corresponding value for that variable. Whatever value it becomes in the hash table in the final stage, it should be the one. This kind of pattern should be used quite often in your simulation for the input program. That will be my tip for you. The hash table will be your friend. Okay? So feel free to use it. And array list, if you want to build some graph, you can also do it as well. And I would say by the end of this week, maybe up until Sunday, I would say definitely meet with your group. And then if you guys want to study together about the coverage criteria and decide which one you want to use, that's fine. Or if you want to delegate the job to a single or some members to decide, that's okay too. I'll leave it completely up to you guys. All right. And starting from next week, after your programming test, you guys should really want to get your hands dirty by diving into Antelope 4. All right. It's so important. Okay. And please make sure by Thursday this week, make sure one of your team members don't give me multiple submissions, just one. Okay? Submit the team.txt. Okay? I need to know who, how many teams we have so we can plan ahead. And we got milestone 1, milestone 2, and etc. So I think that before each milestone, about at least a few days before, I will also give you guys another maybe detailed instruction to tell you what you should really demonstrate on that particular meeting. Okay? So I put the week of a particular day. I'll just give you one example. Let's say for milestone number 1. If you look at the updated calendar, so that means for this particular week, I will give you guys some time you can choose, rather than just a single Friday that we're going to meet with all the teams. Maybe well, if you guys already satisfy the minimum requirements, why wait until Friday? You can get it out of the way. Get a 1%, get a 2%. So I'll give you guys some time. For example, sometimes I may have some 1 or 2 hours on Monday, sometime maybe after class on Tuesday, and etc. I'll let you guys know the time. And then first come, first serve. I will let you guys know when I will share some Google Doc spreadsheets. Your team can just sign up to the slot. And don't override other people's slot. Right? Don't do that. If you do that, people will do that to you too, right? There's no point. All right. All right. So milestone, if the milestones are definitely not challenging to really meet, I think that they're really there to make sure you stay on track. So I can also ask you guys some questions and give you some feedback. Right? That's really the main purpose. Right? All right, the final due dates will be here. And exam on the 10th. All right? It's a nice rehearsal for this Saturday to get a feel what the exam is like, 2 p.m. Right? Sorry, that's the only positive thing I can think of for Saturday. Right? All right, good. Okay, let me see anything else. Yeah, so for the user manual, don't worry too much about it until I give you the template. I'll definitely give you guys more specific details what you guys should really cover. Well, I wouldn't be so, not so many things. There will be some page limits. You definitely don't want to write 100 pages or something, no. I think for last year, the last time I ran the course, maybe no more than 10 pages. We'll see, okay? All right, for the grading, you have already read it, so I think it's pretty much consistent with what I just said, and these are just the additional advanced feature you can support, but feel free to go beyond the list. If you want to have any discussion with me outside of the milestone meeting, let me know. Just come to my office hour as a team or as an individual, either way. All right, the project is very open-ended, so I will love to see what you guys can achieve in 6 weeks. All right? It's definitely much more interesting than when I took the course in 2006, which was only just to translate a subset of C into Pascal. Not very interesting. I think this one is much more interesting, I think. All right. All right, guys, I think that's about what I want to say, at least for now. I think you guys know what to really work on, right? Any question, concern, anything? We're okay, right? Okay. All right. Let me just go back to here. Did I miss anything? Okay, quiz number 3, project just, okay, no, we're done. All right, good. Oh, there are 2 things I want to do today. I want to actually finish until a certain part in the syntactic analysis lecture, and then hopefully we can do that within 30 minutes, I'm hoping. And then for the rest of today, and also Thursday, I want to cover 2 design patterns, namely the composite and the visitor. I think they'll be very useful for your understanding for the project, what you're going to do, right? Since we cannot assume you actually took 3311, it's not a prerequisite, so that's what we're going to do. But for those of you who took it, maybe nice to have a review. I got some nice discussion for today about OOP. If you guys still remember, polymorphism, dynamic binding, generics, maybe, we'll see. Okay, let's now finish this part first. And it's mainly just about derivation versus parse tree, right? So this is the version 3 grammar that we spoke about last Thursday, which would embed the precedence of the operator, which means we're going to go multiplication first and then addition. And I want to go right into what you should know. The leftmost derivation. Given a string, we want to know whether or not it's a member of the language that's actually specified using the context-free grammar. The way to show it is by using some derivation. But there will be some specific way you can actually derive or substitute the variables in each derivation step so that at the end, you can also argue something about ambiguity. That's something we'll see. Okay, just for now. So leftmost derivation. I'm going to do example together with you and also make some points. We're going to keep substituting the leftmost non-terminal or variable. That's the key. All right, let's do example together. Oh, sorry. If you don't mind, let me interrupt. I just forgot to show you one important example about the project. Sorry about that. So in your project specification, I included some link about something called ECL. I even forgot the name. Anyway, something about coverage in Eclipse. I'll show you right away. You don't need to install anything. It works right off the bat on the Eclipse. I'll show you. That might give you some inspiration about what it can support. It's a fancy, polished HTML output. I'll give you one example. You can run any JUnit test against some model classes. For example, in my case, I have a JUnit test class over here. Okay, you can think about it as a test file. I have some other, for example, point v1. So that's the model class that's being tested. You can think about that one as the input program, right? We got input program, we got input test, right? And you can think about if I try to run, right-click on that, and then there's an option called coverage as. Okay, I'm not sure if you guys ever use this. Okay, maybe. Okay, let's do that. If you do that, the output is going to be embedded in the Eclipse. Of course, that part's a little bit different. Right? You can see that part there, two parts. Number one, it's kind of highlighting the code that's being covered by the JUnit test. And also, you can see other classes, for example. Okay, no, that's okay. And you can look at other files as well. And here, sorry, it's a bit small, but it shows some statistics about how much has been covered by the JUnit test. And it's a very nice way to organize the output. If you guys can achieve something along the line with this, that's awesome. Very polished. Okay? And of course, for example, let's say if I want to see specifically how this particular class, let's say this one here, it says 86.4% has been covered. If I click on that, and that one there is going to show to me, I'll make it larger. Right? You can see that's nice. Okay? You can see green here, that means it has been covered. And the yellow here, I believe the condition has been checked, but somehow 17 was not really returned because maybe the condition evaluated false, something like that. So how can you determine which line to highlight? You have to make sure you're able to simulate the test on the input program. That's really the key. All right? Right, that's some nice example for you to refer to. Right? And sorry about the distraction. Let's go back to leftmost derivation. Okay, let's do one example. And this example, don't forget, this example was used as a witness to show version 1 and version 2 of the grammar, which we spoke about last week, was ambiguous. But now this grammar here is not ambiguous. That means it's only one way to do leftmost derivation. There will be some question for us to answer a little bit later. Okay, but let's not do that. Maybe you have done this before, but you have not. Let's do it together. Okay. So, and what I'm going to do is I'm going to have leftmost derivation of the input string, and also at the same time I'm going to draw the parse tree just to show to you. There will be some observation that's so important for us to conclude at the end. Okay, let's do it all together. Let me start with the start variable. That's always the start, only a single one. Okay, let me use the deeper blue. So we'll start with expression. And the parse tree, the root, will also be expression. Okay? And then, in order to derive, since now we talk about leftmost, so the leftmost variable is just expression. And which rule should we choose? We don't have much option. Either we choose this one here, or we choose this one. We cannot choose this one, because if we choose this one here, somehow you're going to get term multiplied by factor. None of them can be derived back to the plus. That's why you cannot choose it. Right? Just understand why you cannot choose it. That's why there's only a unique way to do derivation in this way. Okay? So we're going to choose this one here. Okay? We're going to say expression plus the term. You can think about, okay, I'll do that again. You can think about the term over here. Eventually, it's going to be derived into this. Eventually, okay, just know that. Okay, so we got expression plus the term. let me have a better highlights. You can think about this one here correspond to this one here, eventually, right? All right, let's now move on. And now, if I want to do leftmost derivation, the next step must be a unique variable to substitute. I don't have any choice. Should be expression again, the leftmost over here. And that one there is going to be boiled down into, so now, should I go for the plus rule again, or should I go down to turn? Should be turn, right? Okay. In case you got any question, please just shout to me, in case. Turn plus turn. So when I say turn plus turn, I really meant turn plus turn. Let me give you some look ahead. Given a string, I may ask you to give me the leftmost derivation. Given a parse tree, I may also ask you to give me the corresponding leftmost derivation. That's also possible. Okay? All right, let's now move on. Okay, so the only choice we have is the turn. Okay, and then, so now for this turn here, we can go for the factor. Right? Factor plus turn. So this will be the factor. Right? You can see factor plus turn, factor plus turn. Okay? And then the factor over here, we can get to A. That's a terminating case, which is nice. So that will be A plus turn. Any mistake I made, please let me know. Okay? All right, so now we're going to somehow derive this turn over here to A times A, and then we are done. All right, let's do that. Okay, and then we're going to do, and then the leftmost variable is now turn. Okay, so turn will be maybe turn times factor, right? That's what we need. We need a multiplication. So that'll be A plus turn multiplied by factor. Turn derive into turn multiplied by factor. All right, and the next one should be turn, right? Leftmost. All right, what should that be? Well, it's going to be very similar to how we derive this turn eventually to A. Very similar. Let's do that for completeness. Okay, so A plus, and the term will be go to factor. Multiply by factor. Turn, go to factor. And of course, factor will go to A. So this factor over here, leftmost. And then we're going to do A plus factor go to A. Multiply by factor. We're almost done. We just need one more. Okay, but so far we got factor and derived to A. And this factor, the leftmost, should also be derived to A. A plus A multiplied by A. Right? That's the leftmost. That's the complete leftmost derivation. You guys should know how to do. But you got a solution already in the slide. Are we okay so far? Okay, just make sure you can do it. But for the rightmost derivation, I'll leave that as exercise for you. You can compare your answer with the slides. And several things. Number one, given a string, you want to determine whether or not you can get a leftmost derivation, number one. Number two, given a leftmost derivation, can you draw the corresponding parse tree? Given a parse tree, can you write down the corresponding leftmost derivation? So these are the three things you should know how to do. Okay? And the order of evaluation is also embedded in the way we do the derivation. Especially you can see here, when we got expression plus turn, you can see plus and then turn. Turn must be evaluated before we can do the plus. And the turn itself will evaluate into A plus times A. This tells us we must evaluate A times A first before we can do the plus. Right? So for this part here, this is how you can explain. The order of evaluation is really something you would like to see over here. So before plus can be applied, return must be evaluated first, which will be this particular subtree. And of course, you got to do lots of tree traversal for your project. That's something I'm pretty sure you'll pick up when you do the project. All right. Okay, it's just a few more observation. A parse tree may correspond to, number one, multiple derivation. All right. There's something I want to clarify as well. There is only one derivation over here, only a single one. But why did I say a parse tree, for example, here, may correspond to multiple derivations? Can anybody see why? But I only got one here. How can I have multiple? My hints to you. The one I just has written down is the leftmost derivation. Can I easily create other derivation for the same parse tree? Is it possible? Well, it's possible as long as I don't stick to the leftmost rule, right? Okay. I'll just say, for example, I'll sketch the idea for you. Multiple derivation. So let's say, for example, if you look at this one here, look at this line here. I can easily create another derivation by saying, rather than doing the leftmost, but now I decide to do this one here. And then once I got factor, okay, let me be precise. Let's say these three lines. Okay, multiple derivations over here. Let me write it down. Okay, you can think about ... and then starting from this. Okay, I have a plus factor multiplied by factor. But I decided to do this one first, which is not leftmost. It's apparently a very valid derivation because I'm still applying valid rule, but just not leftmost. It's not even rightmost because all the previous ones are leftmost. The current one is rightmost. It's a mix, right? Okay, and then I'm going to say a plus factor multiplied by a. And now this time I got only one left. That one there is going to be a plus a multiplied by a. So this is the leftmost derivation. This is not. But we got multiple derivations that correspond to the same parse tree. So that's really what this is really saying. Number one. Number two, in terms of the leftmost derivation, we have no option in each step. So it's going to be unique. That's why you got to be very careful. When I say either derivation without specifying how you substitute the variables versus leftmost derivation, right? That's a key thing to watch out for. Guys, are we okay about this? All right. And there will be some symmetric discussion for the same string, but we can do rightmost derivation and also the parse tree. One thing I can do for you is, since it's the same string and the grammar is not ambiguous, so what we can, okay, let me just try to make sure I copy this tree here. That's something I can do for you. If you try to do the exercise over here, you're going to end up with the same tree. Okay, the same. I want to emphasize that. And for the rightmost derivation, that'll be exercise for you. Wow, I'm glad they're happy. Yeah, being happy is important. All right, exercise for you, right? And over here, very quickly. And what I want you to see is about the order of evaluation. If you do the leftmost derivation, you should be able to make the same observation as I did earlier. That's number one, okay? And then multiple derivation, you can easily modify one of the orders not to be rightmost. That's going to create another derivation. That's neither leftmost nor rightmost. But for the rightmost derivation, it's going to be unique. All right? Guys, any question about this? Right? I don't think it's a good idea for me to do rightmost derivation as well. Everybody's going to get bored. right? There's no point. We can dedicate more time for discussing composite pattern. Okay. All right, awesome. And the next 2 pages are simply just considering just a different string, okay? And this, okay, let me just say this. The reason that I want to have 2 example string is this. This is the first string, leftmost and rightmost. Second string, leftmost and rightmost. And you can see here, we don't have any parentheses, but because the grammar is unambiguous. So we're going to do multiplication first, followed by addition. But what if we want to do addition first before multiplication? In that case, we're going to have the parentheses to force the order of evaluation. So this exercise over here, you just make sure, number 1, you can still do the derivation. Number 2, you can still observe the parse tree. Okay, that's the second example. Thank you, William. That's good. At the same time, just stop. Yeah, anyway, thank you. Yeah, guys, any question about this, right? I already said, I think these 2 examples are important for you to see when the grammar is actually not ambiguous, and if you want to force the order of evaluation, you need parentheses. That's the main point, okay? Okay. And final bits to go over before we go to the composite. One slide here about the definition for. Okay, good. Let's say a string may have more than 1 derivations, either leftmost or rightmost or something in between when you create any inconsistent substitution for the order. Okay, so here is one question, which is quite obvious. If I got distinct derivation for the single string, does it really mean I got distinct parse trees? Does it, or does it not? Before I point to Henry. Henry, yes. Is this true or false in general?
I don't want to be too hard about it, but if you have multiple derivations that correspond to the same person.
If you got, not necessarily always, sometimes maybe.
Yeah.
Mm-hmm.
Like even the leftmost and rightmost derivation correspond to the same parse tree.
Oh, for the same string, yes. I thought you just say just multiple arbitrary derivation, yes. So here, okay, let's say for the same string, if I can give you different derivation for the same string, are they going to correspond to the same parse tree?
Say that again.
Basically over there. The statement there.
So same string and different derivations. No, actually different parse trees.
They might have different parse tree. Why?
If the parse tree is ambiguous, then
You mean if the grammar is ambiguous, or?
if the grammar is ambiguous, I can have different parse trees, and each of those parses will have like distinct.
Yeah, that's true. Okay, the grammar may be ambiguous, right? Unless I say distinct derivation for string given that the grammar is unambiguous. Right? In that way, it will be true rather than false. Very good. Okay. Okay, so that's really important for you to get through. And then that's the example we just went through. In that case, you can see in our case about version number 3, we got leftmost derivation, rightmost derivation. If you look at derivation themselves, they are different because we got different order of substituting the variables. But the parse tree turned out to be the same. All right. And final slide for definition. Okay, what does it really mean when we actually got a grammar that's ambiguous? Okay, so let's say a string can be derived ambiguously from grammar if there is 2 or more distinct parse tree. You got different ways to interpret this. Either you can say the grammar will be ambiguous if you can draw different parse tree for the same string. That's one way. That's one. Equivalently, if you say 2 or more distinct leftmost derivation, that means if you keep substituting the same, if you keep substituting the leftmost variables when you do the derivation, if you still get the same different string, if you still get the same string, in that way, it's actually not ambiguous. Okay. Similarly, for rightmost derivation. All right. And yeah. That's about the definition. Guys, are you okay with this definition here? So important. All right? And don't be too surprised. In the quiz or in the exam, if I somehow try to ask you something about definition, for example, think about it. What if I simply say the following? You can make a notes. Here, I say a string is derived ambiguously in grammar if, okay, think about the following question. I'll put it down on the paper. Think about the following. Grammar is ambiguous if there is a string for which there are two or more derivations. Right? And based on your understanding, think about the answer to this question and justify it. Right? Exercise for you. Think about it. Okay? All right. This one here is something we covered before. It's just basically for the same string, you can draw different parse tree. Right? And this is what we discussed last time about the dangling else. We already saw that. Okay? What I want to point out is just one thing here. I'll show you here. I think this one is tricky enough. So I think you may just want to spend a little bit more time after class to see why you can actually draw two different parse trees. Let me explain to you very visually over here. This grammar here, which we looked at the first time last Thursday, briefly. This grammar here is ambiguous. Because if you look at this particular string, okay, let me go over with the string with you. If some Boolean expression, then there seem to be some nested if. Expression 2, then we do assignment 1, otherwise we do assignment 2. That's the string. It turns out this string is a witness for proving that the grammar is ambiguous because you may interpret this sentence differently using the parse tree. Here, I'm just using a parse tree. You can also use maybe two different leftmost derivations to show it. Okay? Exercise over here, use two distinct leftmost derivations to show. That will have the same effects as using the parse tree. Right? I'm just linking to what we just said. And in the first interpretation, the else part belongs to the outer if. So we basically say if expression, and then it's going to be this nested if. Otherwise, it's going to be assignment number 2. That's one interpretation, meaning that the else part belongs to the outer if. A second interpretation for the same string by the same grammar will be when the else part belongs to the inner if over here. So here we say if then, and then this part entirely will be the body for the then part. Right? So you can see if then else. So the else part really belongs to the inner if. So they are different interpretations. So what you really want to study more closely is, number one, convince yourself this one here and this one here are indeed different meanings for the same string. Number 2, can you draw the parse tree? Number 3, can you write the leftmost or rightmost derivation accordingly? Okay, that's the first part you want to study the example about. And number 2, the final part, is about how can we fix it? How can we change the rules so that it's not ambiguous anymore? Okay, magically, this will be the fix. Okay. I wouldn't simply just ask you to memorize this and write that on the exam. That's not the point. Instead, I put a color over here to say, if I want you to compare this one here versus the original one. Put it side by side and try to see why this will be ambiguous, but this will not be. The main thing to pay attention to is to see here we start with the statement here, and then if we got else, we go back to the statement itself rather than going to here. For this part over here with else, which might happen here, if we also got some else part, we also got with else, which will also go back to itself rather than go back to the statement. So we don't have any circularity. That's the key observation you want to have. When you want to convince yourself, this will be the fix. All right? That would be something I would suggest you actually spend some time looking at. The dangling else problem is a very famous one. You want to definitely know what it is about and also have some solution for that. All right? All right, any question so far? For your quiz number 3, I would say it will be reasonable to cover only up to here. I think for the composite pattern, which we're going to discuss, I'll leave that maybe to the next quiz. Okay? So for your quiz number 3, you can already start preparing. I would say we'll go all the way until slide number 32, just for this lecture here. That'll be your quiz number 3 coverage. All right? For next Tuesday. Any question? Why don't we take attendance and then we have a little break? All right? Let me see. Let me start it. Yeah, bear with me. I might need to refresh my location. Just give me 30 seconds to do this. But to get your device ready. Okay, 4302, view the course online. Yeah, it's getting there. Okay, settings, and then attendance, don't require, allowed, and save. Okay, and let me now start a class. Okay, the poll. And then, yeah, I can just use that page over here. That's fine. Yeah, just choose any option just to take a check in. Anyone having difficulty about this? You have difficulty? You do? Okay, come over to the front. Okay. Yeah, meanwhile, we'll resume in just 2 minutes. Okay, don't go too far, and then we'll come back in 2 minutes. We'll start you fresh. Yeah, just find yourself, and then, yeah, anyway. Okay, good. And can I stop it? Can I, right? All right. That's okay. That's okay. Why don't you find your name here and then sign it? Yeah. Good. Thank you so much. Thank you. Good. Oops. Okay, 1 more minute, and then we should get started. All right, let's now start you fresh. Okay, we're gonna move a little bit away from parsing, and let's now talk more about. It's more about the semantic kind of work you can do. Let's say, imagine that you have already generated all the skeleton code from Antler 4, and now you want to somehow organize your model package or expression package. In your case, maybe, I don't know, maybe whatever package you decide to have, right? So the visitor pattern was actually mentioned in the Antler 4 tutorial. We definitely need to cover that. But in order to understand the visitor pattern, you want to understand the target upon which the visitor pattern is applied, which is a composite. So we're going to talk about both. Okay? Don't be too puzzled by the word. Composite simply means tree. You're going to deal with tree structure. Okay? All right. So we're going to see recursive system. So any system or any structure that's kind of recursive, meaning that we got some base case, we got some recursive case, you can definitely use the composite. But before I present to you the solution, I think it will be also useful to actually review, or maybe somehow to look at 3 possible solutions to the same problem. You guys will tell me what's wrong with each one of them. Okay? And that will require some knowledge from the previous OOP course. But we'll see how much you may have remembered. Okay? And also we're gonna, well, I wouldn't really review exactly what they are, but we're gonna use them. You want to know when to use abstract class and when to use interface, right? So that's something you learned back in EECS 2030, right? You want to make sure you can also use them. You use them properly in your project. And the final design attempt will be the composite design pattern. So we'll see how much we can go, but once we finish the composite, we have the sufficient ground to talk about visitor. Okay. All right. Any system that's actually got some individual components and some subsystem, like a subtree, you can definitely use the composite. But let's just see what the problem is. Okay, the one I use is more like a computer hardware example. It's a bit old, like outdated, but anyway, that will do the illustration. Okay, I'm not sure if you guys will still put hardware together yourself, but at least our tech team in the EECS department, they do. Okay, let's say we got some 2 notions of equipments, base versus recursive or composite. So base will be hard drive and CD-ROM. We used to have it in the lab computer, but maybe not anymore. But let's say we keep them. And let's say for the base equipment, they have certain properties, some attributes, or some accessible method you want to support. For example, I want to know what's the unit price for each part. And also, I may want to know what's the power consumption specification for that part, right? That's for the basic one. You can think about all the properties you want to support for the later aggregation. That's something you want to support as a basic property. All right? Bear with me. I'm going to go over this, and then we'll see some diagram for the design. And the composite equipment will be cabinets, buses, and chassis. So these are the 3. So you can think about they are more like a containers. Okay? The container can store multiple equipments. Each equipment can either be composite itself, that's why it's recursive, or base case, basically. Right? That's why it's a tree. Okay, and then what we want to design is a system that will allow us to build such a system that's recursive. This will be just some diagram here, just to show to you that's kind of the system. But you want to think about how this might be related to your project. Not exactly directly related, but you want to think abstractly how they are, because they're both trees. What you want to notice, for example, here, the cabinet here, and also, let's say, let me see. How about this? Chassis over here. So these are the so-called composite. And other things like a power supply, CD-ROM, DVD-ROM, hard drive, and also a card. So these are the base components. The base components basically just represent the leaves of the tree. That's easy. But for the composite, that one there is a little bit interesting. It may contain as one component is the base one. You can see, for example, for the cabinet here, the 3rd component here is a base one. But the 1st and 2nd components for the cabinets, they are themselves composite. That's why the tree will keep growing. Right? That's some important observation. That means later on, if you got your AST from your source input language, for example, your method to really go over the tree itself must be itself recursive as well, because you're going over a recursive structure. That's something you want to keep in mind. Okay? And what we want to do now is to see how we can design classes in Java to solve this. And we're going to do one by one, okay? And before you guys can judge about this design, I will need to explain some notation here to help you, okay? Now, let me help you a bit. The round shape, for example, clients, disk drive, video card, these guys over here, these are just normal Java classes, okay? And I may have some annotation here to say the class should be itself abstract, okay? And then, so for example, here I make the equipment class to be abstract, and also the composite equipment class to be also abstract, okay? The red arrow over here is simply like an inheritance, like extends. Okay? We don't have interface just yet, but in the case of interface, it will be increments keyword. This one here is to really sometimes draw the green arrow to represent like an attribute declaration. I'll show you one example. Okay? This is a diagram. Since we are covering this, I want to cover that properly. So you guys should know how to read the diagram. Okay? So let me show you one example. Let's say we have a class. Let's say students. Let's say here we got maybe some card, YU card, and etc. Okay, let's say that's the class we have. If this is the design of your student class, apparently we have two classes over here. We got student class, also we got a card class. There is the so-called client-supplier relationship, right, as opposed to inheritance. We have to know how to visualize. Okay? You can think about the students is really using some service from the card by declaring these attributes. So we should say the student here is the clients. The card over here is the supplier, providing some service. Okay, are we okay so far? Okay, that's the kind of terminology we're going to use when we talk about the design patterns. And how do we visualize this client-supply relationship? This is how we do it. I'm going to draw one round shape for the students. I'm also going to draw another shape over here for the card. And since we know this is the clients, this is the supplier, there should be a green arrow to go from the clients to the supplier. All right? So we're going to do that. So it's going to be something like this. Okay? It's a client-supplier arrow. And then that means the student being the clients is going to use the service from the card class over here. And the name of the relationship, the connection here is called the YU card. YU card, you can also put the declaration itself. So let me write a little bit better. And of course, sometimes the attribute here may be of type, maybe linked list, or maybe some other data structure. That will still apply. You will see in the later example. Are we okay with this client-supply relationship over here? Okay? Okay, good. Now that you understand the notation, let's now switch to this. This will be design attempt number one. Is this a proper way to represent a recursive system for the computer hardware? And let me help you just one arrow over here, and then I'll let you guys think. So here we are saying that in the equipment class itself is going to declare one attribute called children. The children is going to be a list of equipments. That's how we make it recursive. We're saying that each equipment itself is going to store a list of equipments, like a B tree, basically, right? Guys, take a look at this inheritance hierarchy here, and also client-supply relationship. Do you think this makes real sense as a design? If you don't think so, you gotta give me some counterexample. You might be wondering, what is this? This is more like a hint to help you a bit. You can feel free to see what it's trying to do and try to see if that might help you identify a certain problem. focus more on what's being inherited to the classes. This is an interesting exercise here because we are not showing you the Java code. We're just showing you some conceptual sketch of the diagram. From there, you want to envision what the problem is. William.
Seems like all 5 things are basically the same because the composite equipment is no different. The disk drive, and also doesn't the disk drive and the video card also inherit a list of equipment? It's a little silly because they shouldn't have any children.
Okay, that's good. I like the second. No, that's okay. I like the second problem you raised. Let's focus on that. The second problem you talked about was somehow this and this, the base component, they are categorically different from these, which are composite. But they are inherited, they're inheriting from some common superclass over here, which include children. What's wrong with that?
Can't put any equipment in the disk drive. Like, that should be the end of it. That should be it.
Yeah, that's good. Really, that's pretty good. That's good. So guys, I can tell you that you can put this code into Java. Things might still work, but it's possible for you to have something that simply wouldn't make real sense as follows. So here you can see I got a chassis over here, which is composite. I can definitely add a card and add a disk drive into it. At the same time, the current design wouldn't disallow me to put the following. I can also do, for example, card dot add drive. This will also be allowed because the card over here is a video card. A video card inherits from this equipment class, which has the children. So I can still add. But that doesn't make real sense, even though it works programmatically. That's something you would like to avoid in your design. Okay, so that's why the first design attempt is not really valid. Okay? Very good. That's good. It just goes a little bit quicker than I thought. William, nice job. That's good. Okay, so this one is supported, but doesn't make real sense. If you actually just go back to the slides, it also explains pretty much. All right? Let's improve that. Second one. First thing you should note, you should somehow be able to tell this is a different design, even though it looks so similar. But there are subtle differences. Somehow we can fix the problem that we saw in the first design. Let's see if that's really true before we go further. In this second design, are we able to add equipments into base components? We're not able to, right? You can easily see that. Apparently, you can see for the disk drive and also the video card, they inherit from equipments which only got a property price, right? It does not inherit the children and also the add, which only belongs to the composite equipments. Agree? Okay? So this one over here specifically is going to give you a compilation error. And I want to make sure you guys know why there will be a compilation over here, compilation error. Are you guys comfortable with it? The card over here has the static type video card. That's its static type. And the static type video card does not inherit any children because children is only at this level. That's how you justify, right? Make sure if I ask you this, you will know how to respond. All right? I just want to make sure. All right? That's good. So we improved from the first design. And since only design number 2, we will only get to the ultimate design when we get to number 4. So this still got some problem. And for this one here, I can give you guys a little bit hints. This one has to do something about maintainability of your software. Okay, let me give you hints to lead you a bit. If you look at this class, okay, I'll make it larger. this class actually got two things. Number one, it has a children, which is a list of equipments, very specific type about the components. Each one of them should be equipments. And also we got the add, which is a very standard routine, which will allow us to add the equipments to the end of the children list, right? Do you think this kind of code should be only specific to equipments? Let's say this, for example. Let's say in my project, somehow I want to instantiate the composite structure, not just for equipments. I may want to instantiate that for another type, maybe furniture. I want to put these two things in my project. But both of them want to somehow use the idea about composite. But I already got one composite class here, but it's very specific to equipments because everything is specific to this class. How can I accommodate furniture? That's some question here. I'll put this down here. Hopefully you see my point, right? I think it's really important for you to understand maintainability as well. So this class over here cannot be reused directly for another composite type. For example, furniture. Now, question is, what if I also want to support similar structure for furniture? What should I do?
Make another specific type instead of adding unnecessary.
Yeah, sure. I definitely should really create another composite, but I'm going to duplicate the code, right? Because the children part and the add part, any routine operation I want to do on the composite, they need to be duplicated. Duplication is not good for your design. We say the design smells. We don't really want any duplication. All right? So let me give you some idea. Guys, I can tell you that if you try design number one, design number two, programmatically it might still work, but we want something better from your code. You want design properties, right? Okay, so let me, we'll still got 6 minutes. I'll see how much I can go, okay? If I follow this kind of discussion here, that means I got something like this. In the same projects, I got one part over here just for the equipments. And I got another part over here just for the furniture. Okay, this part here, I'll just put it side by side. And, okay, for example, let's see. In the ultimate design, I will also show you all the class names. For example, here, I might say this one here should be furniture. And maybe this will be a chair, and this will be a desk. So these are the base cases, right? And over here, let's say I only got maybe drawer, maybe a shelf. And what I need to change, maybe the class name should be composite furniture. And this part over here should be changed from equipments to furniture. Well, you can see what I'm doing here, right? I'm simulating what you have to do programmatically. And now, you only have to realize this part over here and this part over here shares a lot in common. They're duplicated. That's not a good design practice. If you find that you have to copy and paste in so many places, that means your design smells. All right. Duplicated code. The design smells. All right. That's the problem. Okay? How do we fix it? So here's my question for you. How can we have a single class that can actually accommodate different types that might be instantiated by the user, maybe to either equipment or furniture? Brilliant. Generic, you guys are good. That's exactly the point. Okay, good. So let's finish that at least for today. When you see the slides, you will see, yeah, we got to use generic. All right? That's what you learned in 2030 or 2011, either way. Okay, now let me show you this. Following you guys suggestion, which is completely promising. What I'm doing now is this. I say I got composite equipment here, but now I factor out the children and also add routine into a separate class, which is itself generic, which means I can instantiate the generic parameter type E here by either equipments or furniture or anything I want. And this part here stays the same. That's not yet the final solution yet. Is there any problem here? I'm saying that the composite equipment here, this guy here, can definitely have the feature of equipment like a price somehow. And also, you can also reuse the routine that's related to composite, which has to do with children or add. And the type is parameterized by some generic parameter. What's wrong with this design? I can tell you the mistake is even much worse than the previous two. It's a tricky one. Okay, I'll pause a little bit longer. No clue, William, this time? Jordan, you want to try? The type? Okay, sure, over here. You mean, are you talking about here? Mm-hmm. Yeah, so here, okay, let me see if this might answer your question. So when I create the composite equipments, it's a particular type of equipment. Oh, sorry, it's a particular type of composite where I simply say I extend the composite, which is over here. And I'm going to instantiate the E over here by equipments. That's what I'm doing. This is, you can do that. This part is okay. William.
I mean, is it that say cabinets instead of chassis instead of cabinets, or is that like fine? And we're just gonna
No, this is okay. This one here is just about equipments, right? You can definitely do symmetric, which I can definitely do. I can just do this part here will be for the furniture. That's fine too, right?
Oh no, not that.
Yeah.
I meant like you can put cabinets instead of chassis, instead of buses, blah blah blah.
Yeah, for sure. No, not that. No, that's not a problem.
Cool.
Good. Henry. Mm-hmm. They can, because that's a good point. Yeah, let me repeat that, that's important, okay? What Henry was bringing up, let's say for the clients, all they declare is an E of type equipments, it's a static type. Polymorphism that you learned from 2030 tells you any class that's of a subtype of equipments can be used, which means this drive, video card, this, all fine. So that's not a concern. Well, I'm glad nobody spotted that. That's what I expected, okay? This is not even going to compile. Do you see why? In Java, can a class extend more than one classes? You can check. Maybe I'm wrong, but at least for the Java I know about, I don't think I tried that on my Eclipse before, but I don't think you can. No, it's something, but Henry, let us know in case we can. I'll be very surprised if it is supported. I'm talking about a class extending from two abstract classes, right? All right, assuming that's right, right? Guys, you cannot, there's something called multiple inheritance, all right? The reason I'm not just trying to trick you guys, it's a very valid decision to make when you design, okay? I'm going to just pause over here, but I'm going to pick up from here. Basically, when you program in Java, at the design level, you will easily think about idea related to multiple inheritance, like what we just discussed. However, to really make it work, you will have to make some workaround using a mix of abstract classes and interface. That's something I'll show to you in the final design. right? But so important for you to know why this wouldn't compile. All right, guys, I'll see you on Thursday.